Hello! So today we're going to be talking about the cube root of -1 and why the answer is not just -1. And in fact, there are complex solutions to this. And this came up because one of my students asked me about it and they mentioned, oh, could I be part of a solution to this? And I was like, wait, what? And then I chatted about it to a colleague and he was like, just try it, just see what you can find. And so I used this method that I'm going to talk about, which kind of worked, which was really cool. So I'm going to want to share that method, and actually you can use it to generalize finding the complex roots of any real number. So here we go. We have the cube root of -1. And really what we're trying to do is we're trying to think of what is the answer to some number cubed equals to -1. And the first answer is obvious. We know that that something could equal to -1 because -1 cubed equals -1. But what if the number in this box was complex? In which case, it is some real number plus some imaginary number. It has real and imaginary components. What would that look like? And actually, what we can do is we can write that number, all cubed, equals to -1. And if we solve this problem, we get what x plus iy must be, and so we get what that complex cube root of -1 is, which is really nice. So before we start, let's just look at imaginary numbers very, very briefly and quickly. I is the square root of -1. I'm going to assume a bit of knowledge, but what's nice about this method is you don't really need to know that much about complex numbers to work this out. So we have I equals the square root of -1. We also have that I squared is that squared. The cube root of -1 squared just give me -1. I cubed is -I because it's -1 times I. And those are the three things we're going to be using when we actually expand this cubic on our left. So let's start expanding it. I'm going to write it out. We've got x plus iy times x plus iy times x plus iy. I'm going to start just by expanding these two, and then I'm going to multiply it by the last bracket. So I get x squared plus ixy plus ixy plus I squared y squared. And remember, this is all going to be times by x plus iy. So let's do that. Multiplying the x by the x squared, we get x cubed. Then the iy by the x squared, we get plus x squared iy. And similarly, I'm going to go down and multiply all the other terms. So I've got plus ix squared y plus I squared xy squared. That was this term times this term. And then actually I have the same thing again. So I've got ix squared y plus I squared xy squared. Trying to be careful not to make any silly mistakes here. Finally, I've got plus I squared y squared x plus I cubed y cubed. Whew, that is a lot. Now remember, we're only dealing with our left-hand side here. So let's simplify this. We've got a lot of like terms. Let's deal with the i's first. So this here and this here we can replace with -1. Let's get a pen. With this is -1 and this is -1. Similarly, the I cubed, this guy, oh, I don't want black. This guy we've seen from up here is just -I. So what we have is x cubed plus 2x squared iy plus I squared. Oh, we've got another I squared. Let's deal with this guy. That also goes to -1. That's also -1. So, just grinding through some of the algebra here, minus xy squared plus ix squared y. Oh, look, we've got another one of those. Minus xy squared minus y squared x, which is exactly the same, minus iy cubed. So, that simplifies to x cubed plus 3x squared yi minus 3xy squared minus iy cubed. Whew. And actually, once you've done this once, because this is general, you always end up cubing the same thing, x plus iy, you're going to get quicker at it. So we have this, and we know that all of this is equivalent to -1. That is what we are claiming, and we want to work out what x and y are. So we have that x cubed minus 3xy squared plus 3 x squared yi minus I y cubed is equivalent to minus 1. And what we're going to do to solve this is we're going to compare coefficients. And what I mean by that is we've collected together our real parts on our left-hand side, x cubed minus 3xy squared. And we can actually factorize out the I. And so we have our complex parts. And this is still equivalent to minus 1. And what we're going to do is we can compare those. Because x and y are real numbers, we know that this section here has to equal minus 1. Our real part of our left-hand side equals our real part of our right-hand side. Similarly, the imaginary part of our left-hand side has to equal the imaginary part of our right-hand side, which actually, well, there's nothing there. We have 0i, which means that we end up with some simultaneous equations. X cubed minus 3xy squared is equivalent to minus 1, or is equal to minus 1, sorry. Let's just get rid of one of these lines. Similarly, we have that 3x squared y minus y cubed equals to 0. And what's cool about this is you can see how it can be expanded generally, because the only thing that's really changed here is this, the minus 1. This part is always going to be the same when you're doing this, because it's just the imaginary part and it's always going to be equal to 0, because we are finding the cube root of some real number. This bit is always the same as well. The only thing that's changed is whatever this is. So this is always going to be replaced with whatever real number we're trying to cube root. And now we have these simultaneous equations, which you could solve through with lots of messy algebra. What I'm going to do is I'm just going to use Desmos. I'm just going to use a graphing calculator to do this. So I've plotted both of these graphs, and the solution to these simultaneous equations is just the intersections here. 0.5, x is 0.5, y is 0.866, and x is 0.5, and y is minus 0.866. These are my two solutions. So let's grab those. And actually, you might recognize these solutions or these numbers because these are just plus and minus root 3 over 2, which is actually usually how this is written. But either way, we get that x equals to a half, and when x is a half, y equals 0.866, and x is a half, y equals to minus 0.866. Or we can write them as root 3 over 2 and minus root 3 over 2, which means that the cube root of minus 1 is minus 1, or a half plus root 3 over 2i, or we could be saying and here, minus root 3 over 2i. There we go. We've got our three solutions to this. We've got the cube root of minus 1 is minus 1, or a half plus root 3 over 2i, because remember we were just subbing x and y into this, which is so neat. And actually, these solutions are obviously the exact same solutions you get from doing other methods which I will link here in the video. Probably neater methods, but what's nice about it doesn't require a lot of knowledge of complex numbers to find this out. So can you think about how you might extend this to find the cube root of minus 5, or the complex parts of the cube root of 6? All that would change is whatever this number here would be replaced with this number here. Everything else is exactly the same. So there we go. The cube root of minus 1 is minus 1, and a half plus root 3 over 2i, and a half minus root 3 over 2i. How lovely is that? Thanks for watching.